Hello, 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 Start our lesson now. We are looking at the projectile motion. So we are very familiar. We are very familiar with the linear motion. Where we have the equations for linear motion. One of the equations for linear motion is actually displacement is equal to initial velocity plus half times acceleration times t squared. So S is actually displacement. And U is actually initial velocity. And T is actually time. And A is actually acceleration. Is actually acceleration. So the other equation that we have is actually final velocity is equal to initial velocity plus acceleration times time. And so for a two-dimension motion, which has actually the y-axis and the x-axis. We are dealing with now what is known as a projectile motion. Well, projectile motion, we will talk about an object, for example, moving in two dimensions in the x, and if this is in the x and y axis, if x is our a horizontal motion, and this one is the vertical motion. So we have vertical motion of the object in the plane, and this is the horizontal motion. And so this object is moving with velocity v(o), and so at an angle theta, and therefore if you are to break it into components, if you break this in two components, means that this becomes VO sine theta, while this one is VO cos theta. And so this is the vertical motion, VO sine theta, and this is the horizontal motion, VO cos theta. And so VO sine theta, you can say this is the velocity in the of the in the y-axis, while VO cos theta is the velocity in the x-axis. And so we can calculate the time that the flight, if it's launched from this point to up to this point A, the time that it can take. So you can look at the time of the flight, time of the flight for the object. We use our basic equation, for linear motion. Basic equation for linear motion. We are aware that displacement, which we defined here, is the displacement. Displacement is equal to initial velocity multiplied by time plus half at squared. So for an object which is moving upwards, we note that it will start from 0 and it will go up and it comes back to 0, meaning the height is actually, the displacement it has covered is actually 0. And then the initial velocity, meaning this is the velocity of the object vertically, and then we have half multiplied by acceleration due to gravity, so this one becomes acceleration due to gravity. And so we can factor out the time, and meaning we are going to VOY plus for an object which is going upwards, so this becomes negative, and then GT is equal to 0. And so this is, so we can, from here we can say time is equal to 0, and also 0 is equal to actually VOY minus half multiplied by, I can write this one here, which is 0 is equal to VOY minus half multiplied by T. And we are aware that this is the vertical motion of the object, which is VO sine theta minus half T is equal to 0. So you can make T the subject of the formula. So you can bring half T is equal to VO sine theta. Meaning that here we can make T the subject of the formula, which is actually T is equal to 2 VO sine theta divided by, actually you see here we have actually I've left G here. And this one there. So this one becomes G. So this is the time for the flight. So this is the time of the flight. So time of the whole flight is actually T equal to P O Y over G, which is equal to 2 V or initial side theta over G. So this is the time of the flight. So I just wanted to explain that this is the time of the flight. Okay. Okay, so huh? What? Huh?